Okay, so here we have this plane-related rate problem. It says that an airplane flying at 450 kilometers per hour at a constant altitude of 5 kilometers is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta, remember this is a key word, when theta equals pi over 3, how fast does the camera have to rotate in order to keep the plane in view? Okay, so remember the very first thing we need to do is we need to draw a picture, and I'll try to use my my limited drawing ability. But let's say we have a little plane here. This is a shark plane. Has pointy arrows and a shark teeth. There we go. That's my plane. Okay, and then we have a camera down here on the ground. Let's see right here. This is the camera. And so here, this camera is pointing towards the plane, and the elevation of the plane from the camera is going to be 5 kilometers. Okay, now it says the plane is flying at 450 kilometers per hour. And so let's assign this a variable. Let's call this, well, okay, first thing, notice that this is a rate, so kilometers per hour. That means that this is going to be a derivative, and the units basically tell you what the derivative is going to be of. So this is going to be the derivative of, let's call this plane, let's just call it A for airplane, with respect to time, because time is in hours. Okay, but now this A has to represent, it has to correspond to this rate. So this is the rate at which the plane is flying, so that means that A would have to be the distance from the plane to the camera. So this would have to be A. And now notice that, so this is A, so that means the derivative of A with respect to time, this is going to equal 450. But now you have to be a little bit careful here, because notice that A, as the plane moves over this way, and you should always check this, notice that A is going to get smaller. And if A is getting smaller, that means the derivative is going to have to be negative. And that's really important right there. Okay, so let's put that down. dA over dt is going to equal negative 450. Okay. Alright, so we already labeled this. The altitude is 5 kilometers. Here I have it on my picture, and that's constant. This is important, that this is constant, so we can put it in right away. Okay, now let's let theta be the angle of elevation, so that means right here we have an angle, theta. Let's put it green. Theta is the angle of elevation, and notice that this is not a constant, this one's variable. As the plane moves closer to the camera, this angle is going to get bigger and bigger and bigger. Now remember this key word when, this value, theta equals pi over 3, we don't just say that theta is going to equal pi over 3. This is a particular point in time when we're evaluating, and this we only find in the very end. Okay, now here we have to make sure we understand what exactly we're looking for. This is asking how fast does the camera have to rotate in order to keep the plane in view. Okay, so how fast, that means we're talking about the derivative, because derivative is a rate. Now, how fast does the camera have to rotate? Okay, so you ask yourself, okay, what measures how something rotates? Well, that's the angle, right? So that means that what we're looking for is how fast the angle is changing with respect to time. Okay, so what we're looking for is d theta over dt when theta equals pi over 3. And this is key. Setting up the actual question that you are trying to find the answer to is really, really, really important, because otherwise you can't answer the question. Okay, so that is, remember, step 1, drawing a picture and labeling everything. Okay, then you move on to step 2. So remember, step 2 is finding a formula that relates all of your information. And so here, notice you have an angle. Here you have, you know that this altitude is always 5 kilometers, and A, well, we don't know what A is, but this is a variable that we have the derivative of, so we could potentially maybe find A. So a formula that relates all of this information is that we know that tangent of theta is equal to 5 over A. Okay, so once you have your formula, remember what you do is you get the derivative of both sides. So here we're going to get the derivative of tangent, which is the left side, and the derivative of 5 over A, which is the right side. Okay, and so we get the derivative of both sides implicitly. Well, what we're going to get is the derivative of tangent. Well, that's secant squared theta. But then we have to multiply this by the derivative of the inside. And since theta is a function of time, that means we have to multiply it by the derivative of theta with respect to time. Okay, and this is equal to the derivative of 5 over A. Well, remember, if you bring A up to the top and use the chain rule, we would get negative 5 over A squared. And then times, since A is also a function of time, we have to multiply it by dA over dt. Okay, and so then you take a look at this formula and you plug in what you have and you find whatever else it is that you need. So for example, here, now that we got the derivative of both sides, now we can plug in our when value. So it's exactly when theta equals pi over 3. So when theta equals pi over 3, that means I can plug in pi over 3 here. d theta over dt, this is the one that I'm looking for, so I'm going to leave it alone. dA over dt, I know what that is. That is negative 450 kilometers per hour. And A, well, I don't know what A is. But if I take a look here, well, if I know that theta is going to equal now pi over 3, well, I could use my original formula to figure out what A is. If I take a look at my original tangent, well, A is going to equal, if I just crisscross these, I'm going to get A is equal to 5 over tangent of pi over 3. Okay, so tangent of pi over 3, remember that's equal to square root of 3. And so now I can use this down here and plug it into 5 over square root of 3. Okay, so then I plug it all in. Secant, so remember secant is 1 over cosine. So cosine of pi over 3, that's 1/2. And so secant squared is going to be 2 squared, which is 4, times d theta over dt equals, here I'm going to have negative 5 over 25 over 3 times negative 450. Okay, and so then I get 4 times, just a little more algebra here. If I do my tortilla rule and multiply all this out, I'm going to get 270. And last but not least, divide by 4 on both sides, and I get that d theta over dt is equal to 67.5. And this is going to be in, so this is going to be 67.5 radians per hour, which is about, we can think of it as 1 radian per minute for that plane to stay inside of the camera. And that's it.